More DIY solar. Many of you may not be up to this, but I'm not going to tell you your limitations. This is the part 2 of the KEGERATOR, which is a refrigerator control based on sampling the initial voltage of the battery, turning on the refrigerator, and turning it off when the battery gets down to a certain voltage level, way above what would be considered a normal discharge. So most of these parts you can get out of the compost of consumer electronics that we have around all the time. You don't really have to spend any money on solar. That's what I'm all about. Okay, initially what we have is a voltage sensing circuit using an LM431 or a TL431. Anything with a 431 on it will be likely one of these chips. You can find it in any wall wart, most old VCRs and things like that that have a switch mode power supply. So the 431 transitions at 2.5 volts. So you can get on any internet voltage calculator and figure out what voltage you want. The 2.5 volts is rather precise, so if you choose resistors, it'll switch at that voltage. So when this voltage gets above 2.5 volts, this begins conducting. It goes down to 2 or 1.8 volts, just enough to keep the chip inside active, and that biases this transistor up here. It's a PNP transistor, and most transistors, it's any silicon one, most, even a marginal one will have a gain of at least 60, which is more than enough to drive the relay. So when this turns on, it feeds current down to here and closes this relay. This lower LM431, that's set up at a much lower voltage, so when this turns on, this one will already be turned on, so this relay will close. When it closes, the relay contacts will power through this diode and it'll latch on, because whatever voltage you tripped at will drop rather quickly. So you need something that latches. This LED here, we have a 470 ohm resistor across it, because these take a little bit of current just to operate, and LEDs will work down to microamps. And so to get rid of the dull glow, we put a resistor across it. We use some filter capacitors, so we're not affected by little momentary noise glitches that might be on the battery, and sudden changes in voltage to false trip it out. Anything from 1 UF to 4.7 will work, even higher if you want. So when this turns on, it powers the W1209, which is your temperature controller, and that is totally unpowered before you get up to the battery voltage that will cause the thing to latch on, which is a nice feature, because this thing only draws about 1 milliamp while it's waiting, and even when this relay closes, it's only about 40 milliamps. Now the relay here, the one I used is 375 ohms. You can grab these out of any old VCR or TV maybe. This one is 557. This is actually what they call a TV relay. Yep, UL has a rating for just TVs. And these tend to be very low current because they only have a normally open contact. So they don't have a big heavy spring trying to open them back up and make a good contact with the normally closed. This one here is 262 ohms. That's really too low. I mean, you can find relays that are as low as 150 ohms at 12 volts. Avoid those. I mean, there's no use wasting a lot of current while this thing is on. these relays are around, so remember, try and get something at least 400 ohms, and that will cut down the amount of current that's used. Now these LM431s, they can be found in any wall wart. If it says 431 on it, it's more likely one. This one, we have set the switch at 12.5 volts. And if you want to raise that up, basically about every 300 ohms will give you 0.1 volts. Now this, I've made this adjustable to a lot lower than I would normally like, because you may want to use this as a pump control. A lot of people have a pump at their camp and they want it to operate during the day, but they don't want it to operate during the night. And so when the voltage drops down, indicating basically there's no sun, it'll turn the system off so the pump won't run even if there's demand for it. Now the PNP transistor, they're actually kind of hard to find in a lot of electronics. Most electronics stay with an NPN, but like if you're taking apart a wall wart, it'll probably have a PC817. That's an opto-isolator, and basically we use that to invert. You change this resistor to 820 ohms, so we have 12 milliamps going through this. Now the thing about opto-isolators is they do have gain to them, but it can be as low as 30%. So if you put 12 mA through there, you may only get 8 mA. And if you do a PC817, if there's a C or a D on it, that's indicating it's a fairly high gain. And those can be up to from 200 to 600%. And if there's no marking on it, it can be anything too. So you best try it out first, and just connect this 820 ohms to your common and see if it can turn on a relay. This is where having a low power relay is a big advantage. So that's the circuit. I'll pull back here a little bit. Here's the pin out for the 431. You have this reference pin. The center pin always goes to ground. The cathode is always driving the relay. So if there's any questions, ask. Hope you found this interesting.